This is Unit 7, Lesson 8, and then in this unit we're going to learn how to solve quadratic equations using square roots. Anytime they ask us to solve any kind of polynomial equation, they're asking us to find the roots. So this is the simplest type of these type of equations. And as we move forward, we will talk about exponents that have a higher power and how to solve or find the roots of those equations. So here, the first thing I'm going to do is I'm going to subtract the 18. So I'm just going to try to get the x squared by itself. If I can't, then I'm going to move everything to one side and factor. Usually that will take care of it. But for this one, it's easiest if I keep the x squared on the left and then move the 18 to the other side. So that would be negative 35. And then if I divide by the negative, I'll have x squared equals positive 35. And then to solve this, all I have to do is take the square root of both sides. And remember, we've talked about this before. If we put in the square root, we have to include a plus minus in front of our answer. So we have plus minus, and that would just be the square root of 35. 35 is 5 times 7, so nothing comes out of that. There are no two common roots. So plus and minus square root of 35, that would be our answer. Don't change it to decimals, leave it this way. This is simplified radical form, and that's what we want, unless the directions tell you to do otherwise. For this one, again, I'm going to get the 5 on the other side, so I have negative 3x squared equals 21. I'm going to divide by the negative 3, so I have x squared equals negative 7. And then again, I'm going to take the square root of both sides. On the left, I have an x. On the right, I have positive and negative, plus and minus, I times the square root of 7. So we have two complex roots for that one. On this one, it might be tempting to FOIL this and then move everything to the other side and try to factor, but there's an easier way to do this. So I want to make sure I show you this method as well. I'm going to subtract the 2 over. So that leaves me with 4 times x minus 1 squared equals 24. Then I'm going to divide by the 4. So I've got x plus 1 squared equals 6. And then all I have to do to get this portion of the problem by itself is take the square root of both sides. So I'm going to do that, take the square root of both sides. Now, when I do that, over here, I still need a plus minus square root of 6. Over here, I would just have an x plus 1. Now remember, we said earlier in the year that if we take the square root and it went from an even to an odd power, we need absolute value. But since we have put the plus minus in front of the square root of 6, that takes care of the absolute value. Because remember, when we have an absolute value around something, we set up two different equations, one with a positive and one with a negative. So putting the plus minus takes care of that. So we don't have to worry about that in this situation. And so then I'm going to subtract the 1 over. So I've got negative 1 plus or minus the square root of 6. It's fine to leave your answer like this. Those are two real irrational numbers, and there's nothing wrong with that. There is no need to write it out as negative 1 plus square root of 6 and negative 1 minus square root of 6. There's nothing else you can do with this. Just leave it like that. Here are two more equations for this one. I'm first going to subtract the 10 over. So I've got 2 times 2x minus 8 squared equals negative 18. I'm going to divide both sides by 2. So I've got 2x minus 8 squared equals negative 9. Then I'm going to take the square root of both sides. When I do that, this side is 2x minus 8. And over here, I have a plus minus 3i, because that's an imaginary root. And then I'm going to add the 8 over. So that's 8 plus or minus 3i. Now remember, we can't add those together because the 3 has the I attached to it and the 8 does not. And then we're going to divide by 2. So I have 8 plus or minus 3i divided by 2. And that's all I can do with that one. I'm going to leave it this way. I've got two complex roots there. In the next one, I'm going to subtract the 9. So that'll be negative 23. Then I'm going to divide by the 16. To get negative 23 over 16. And then I'm going to add the 2. I'm going to use a calculator for that because that's the difficult. So I've got x squared equals negative 23 over 16 plus 2 gives me 9/16. And then to solve that, I'm going to take the square root of both sides So I've got x equals plus and minus. The square root of 9 is 3, and the square root of 16 is 4. So that's plus and minus 3/4. So my two answers there are positive 3/4 and negative 3/4.